let's go ahead and talk about the chain rule. And the chain rule is used for composite functions, basically a function inside of another function. Let's say if we have a function f of x, and this is going to be equal to, let's say, x to the third power. And let's say if I have another function, g of x is equal to, let's say, the square root of x. All right. So now what I can do is I can say, okay, I'm going to put one function inside of the other function. And hopefully y'all know how to evaluate out these composite functions. Let's say if I wanted g of f of x, how would I do that? Well, g of x is equal to the square root of x. So g of f of x means that everywhere that I see an x, I'm just going to replace it with f of x, which is x to the third power. So this is just going to be the square root of x to the third power. All right, let's just do another example just to be sure that we're on the same page here. All right, let's say that we have sine of x. All right, f of x is sine of x. And let's say that we got g of x being equal to x squared. What is g of f of x in this case? Well, if g of x is equal to x squared, well then g of f of x, everywhere that I see an x, I'm just going to replace it with an f of x. So this is just going to be equal to sine of x. And I'm just going to be squaring this thing, right? Everywhere that I see an x, I just replace it with f of x, because f of x is sine of x. This is just going to be, well, I substitute sine of x into x, sine of x squared. So the chain rule tells me that if I want to take the derivative of a composite function, a function inside of another function, what I do is first I just take the derivative of the outside function like normal, except everywhere I see an x, I'm just going to replace it with a g of x. And then I'll just multiply by that. I'll just multiply that by the derivative of g of x. Let's do this example. So in this case, f of g of x, my f of g of x, what is that going to be equal to? Well, f of x is equal to sine of x. So f of g of x, well, everywhere that I see an x, I'm just going to replace it with x squared. So f of g of x, you notice that this is slightly different from the composite function we did before. This time we're substituting x squared into this x. So this is just going to be sine of x squared, right? Everywhere we see x, we replace it with a g of x, which is x squared. Now, how do we take the derivative of this function? Notice how my outside function is f, right? F of x is my outside function. And you can see it you can just view it from here as well. Sine of x is my outside function, and my inside function is x squared. So what I do is first, I just take the derivative of the outside function. So what's the derivative of sine of x? That's cosine of x, right? It's cosine of x. And sorry, I gotta remember to put the derivative operator here to show that we're trying to take the derivative of all of this. But the derivative of sine of x is equal to cosine of x, right? But right here, we have f prime of g of x, meaning that I'm just going to take the derivative of f of x, and then everywhere I see x, I'm just going to substitute it with g of x. So instead of cosine of x that I have here, it's going to be cosine of x squared. Everywhere I see x, I just replace it with g of x, which is x squared. And then I'll just multiply that by the derivative of g of x, which is, well, the derivative of x squared is just going to be 2x. And that's going to be my answer. Let's do another problem like this. Okay, let's say if we want to take the derivative with respect to x of x plus 3 to the 6th power. Obviously, I do not want to multiply, FOIL, expand all of this out. That's going to take forever. So instead, you can use the chain rule. What's my inside function? My inside function is x plus 3, right? That's just what's on the inside. But my outside function, this might be a little hard to visualize, but this is just going to be x to the 6th power. Imagine putting everywhere, imagine in this x right over here, I replaced it with x plus 3, right? So then I would get x plus 3 squared, x plus 3 to the 6th power, right? So this would be my f of g of x right over here. Now, how do I take the derivative? Well, first, imagine that you're just taking the normal derivative, all right? If I'm just doing this normally, I would just use the power rule, right? This is just going to be 6x to 5th power. But remember, everywhere that I see this x, I'm just going to replace it with a g of x. So this is actually going to be x, all right? So that's an important thing to know. Substituting g of x whenever you differentiate the outer function. And you're just going to multiply by the inside function. So what's the derivative of x plus 3? That's just going to be 1. So that ultimately, this is just going to be my answer. Let's just do this one. What's my outer and what's my inner function? Well, it looks like my outside function is e to the x. F of x, my outside function, is equal to e to the x. And the thing on the inside is 2x right over here. That's my inner function, right? G of x is equal to 2x. And that makes sense, right? Imagine if I have the function e to the x, but everywhere I see x, I just replace it with 2x. So I get e to the 2x, right? Now, how do I differentiate this? Well, how would you differentiate e to the x normally? The derivative of e to the x is just going to be e to the x, right? So I'm just going to write down e to the x. However, remember, when you're differentiating f of x, it's with respect to g of x, meaning that everywhere you see x, you're just going to plug in g of x. So this is actually still going to be e to the 2x. However, don't forget, you have to multiply by the derivative of the inside function. My inside function is 2x, and the derivative of 2x is just going to be 2. So my answer is 2e to the 2x. And, well, whenever you're trying to do these problems, well, it becomes a lot simpler. For example, if I have e to the 10x, my derivative will just be 10e to the 10x, right? So you kind of just, it's kind of like the power rule where you just slap down the coefficient, right? You slap it down to be the coefficient, but in this case, we're not actually changing the power anyway, all right? So a lot of you guys might also see the chain rule formula be written in sort of the fraction notation, all right? I know that's a little bit informal. Instead of calling, this f of g of x, we can just say that this function right over here is equal to y, right? So all of this would just be the derivative of y, which is our, f of g of x term, with respect to x. So that means that as x changes, we want to find out, if we make a very tiny change in the x value, how's that going to affect the y value? For example, take a look at this right over here. You have f of x equals x squared, g of x is equal to x plus 3, and x plus 3 squared is going to be f of g of x, right? Now, I know that if I make a change to x, so if I make a change in my x value, that's going to cause a change in my inner function, right? My inner function is x plus 3, just x plus 3, right? That's my inside function, g of x. If I change my x value a little bit, that's going to cause a change in my inner function, And therefore, that's going to cause a change in my final value, right? Change in my final value, right? So once again, for example, if I change my x value a little bit here, well, that's going to cause a change in my inside function, which in return is going to cause a change in the entire value of this x plus 3 squared. And that's literally exactly the chain rule. It's like the chain of events that's happening. So we can imagine if we call this entire function right over here u. If I change u a little bit, I change the inner function a little bit, that's going to cause a change to the output. However, changing my x value causes a change in u, and that's going to be my chain rule, right? If I change my x value a little bit, I change the inside function value a little bit, well, that's going to cause a change in this entire sort of inside function, right? And a change in the inside function causes a change in my output value, right? If I change this x plus 3 term by a little bit, that's going to cause a change in my output value. And that's literally the chain rule.